Hello, hello, hello.
So good morning.
Good morning, good morning. Just I am checking whether I am connected or not.
Good morning, sir.
Good morning.
Good morning, everyone. We are just about to begin the inaugural ceremony.
Hello? Hello?
Yes, sir.
Okay. Just now I'm checking whether I'm on the line or not.
Sir. Good morning, everyone. I hope you all are healthy and safe. With immense pleasure and great excitement, I extend my warm welcome to the dignitaries, our resource persons, faculty member of our institute, participants from various colleges across India on the inaugural ceremony of this 1 week online short-term training program on multi-objective optimization methods for engineering and scientific application. This 1 week short term training program is sponsored by AICTE New Delhi and organized by Department of Mechanical Engineering at Sri Shankaracharya Technical Campus, Bhilai. Dear participants, Sri Shankaracharya Technical Campus is a NAC A-grade leading institute in the state of Chhattisgarh with all its engineering branches accredited by National Board of Accreditation, New Delhi. I'm happy and proud to share with you all that we have recently been conferred with autonomous status by University Grant Commission. With a vision to create the ambience of academic excellence in which the new idea and research flourish, our institute has always been leading in organizing various activities to cater the same. This time, we are here with a 1 week short term training program with an objective to enrich the knowledge of our participants through interaction with the experts from academia. Dear participants, this program is designed with an intent to explore the multi-objective optimization and their application in various industries for quality improvement and offline quality control. This STTP will provide a platform through which participants will obtain information about recent advancements in the field of optimization and its application. The main focus of the program will be on educating the potential users of optimization methodologies. This program also aims to discuss theoretical and practical aspects which are of interest of practicing engineers, research scholars and students. We hope this 1 week online short-term training program on multi-objective optimization methods for engineering and scientific application, which is sponsored by AICTE and hosted by Department of Mechanical Engineering at SSTC, will expand the knowledge base and benefit the participants at large. What makes this effort more exciting that we have a sizable number of participants pan-India. To ensure that the learning is effortless and easy to follow during this 1 week STTP, we will have with us esteemed panel of speakers from IIT BHU, NIT Rourkela, Institute of Infrastructure Technology Research and Management, Ahmedabad, Indian Institute of Information Technology Design and Manufacturing, Jabalpur and Kurnool, and Madan Mohan Malviya University of Technology, Gorakhpur. We are happy that we have such esteemed panel of speakers with us. Before we begin, I, on behalf of organizing committee, would like to thank our chairman, Sri I.P. Mishra sir, and president, Madam Jaya Mishra, for always being the source of motivation. To encourage us and support us in our endeavor, we have with us Dr. P.B. Deshmukh sir, Director SSTC, who is also the Chief Coordinator of this short-term training program. Now, I request Dr. P.B. Deshmukh sir to address the participants with his words of wisdom and declare this short-term training program open. Over to you, sir.
A very good morning to all you, respected, honorable, all resource person, the organizing committee, Dr. Ajay Verma, Dr. Mahesh Singh, Madam Viva Bhandari, all participants, faculty of the Mechanical Department of Mechanical Engineering. Really, it is very honor for us to organize this AICTE sponsored short-term training program on multi-objective optimization method for engineering and scientific application. This is a second series on the same line, and this 5 days program is a very important in view of the recent developments and in the dynamic change that we are observing, particularly after this COVID-19. This optimization method, optimization. This concept has been the interdisciplinary parameter vectors, and it is applicable irrespective of the field. The reason is that the optimization generally we say it is nothing but maximize your output with the utilization of minimum input. So definitely with this concept, these optimization methods are there, and lot of research are also going on, and new theory and practices are being developed. We have seen that in the recent time, generally if you go through that, apart from this your scientific and engineering and scientific applications, now the COVID vaccines are to be given to the 125 crore people in our country. So definitely it is very means limited resources as a medicine, as a vaccine, and we have to distribute it in a very optimized way, so that priority has to be decided at all levels, and then with limited vaccine we have to perform the work. This is a very recent case of optimization. Therefore, the people are going scientific, so many calculations on that. Models will be applicable, and on the basis of the model, the program will be formulated. The total plan will be to be executed in such a manner that the needy people will be the first and followed by the next and next. So this is nothing but an exercise of the optimization method. As we see it is application at the administrative area. Similarly, there are a lot of areas, particularly in the industries and in the scientific areas, we have to go for optimization, and optimization is generally, I perceive, it is a psychological term. Optimization means minimum with a minimum input, how we can maximize the output. Therefore, it is a concept of minimization and maximization, and between that, we have to go for the optimization. So with this, I think there are so many methods are there, and that methods for particularly it is a PCA, NGW, Mura. Then there is a TOPSIS, some design experiments are there. There are the meta heuristic algorithm are there. There are the non-linear optimization method, and so many things are there. Therefore, I am very thankful to our resource persons. We have considered our request for giving an input to all our participants, and I am very grateful and thankful to Dr. S.S. Mahapatra and Dr. Arshad Javed, Dr. Rajesh Verma, Dr. Akhtar Khan, Dr. Kumar Abhishek, Dr. Dilip Kumar Gupta, Dr. Saurabh Pratap, Dr. Himanshu Nanda, Dr. Deep Mala, various institutions, very great institutions, importance Institute of for Higher Education and important like NIT, BA, BITS Pilani, MMU, IIT, DM, Ahmedabad, IITR, RAM, and IIT BHU Varanasi. I hope with this input from our very honorable resource person, all participants will get a very good knowledge, very good expertise as far as possible and input, so that this will be a very fruitful and useful workshop for them. This Shankaracharya Technical Campus is generally is organizing the number of workshops in this area, and particularly this Shankaracharya Technical Campus, it is a NEC A grade institution with all its engineering branches. BTech branches have been accredited by NBA, as well as we have been placed in the NRI ranking into 50 to 300 bands, and recently we have got the status of autonomous institute conferred by the UGC. Therefore, we are going in a very long run with a very good vision, and at the same time, we think and we hope that along with our faculty member and the other faculty members throughout the country, they will be benefited with the number of knowledge, number of inputs, and in view of that, we are organizing this AICT short-term training program in a multi-objective optimization method. This year, we have came with a number of branches in emerging areas like artificial intelligence and machine learning, data sciences, and then IoTs and big data analytics and so on. But when I go through that, I find that there is a very big importance of optimization in AI, artificial intelligence. Artificial intelligence is nothing but it has been pursued from our natural intelligence which we are having with us. And always, what is our nature? Our nature is that always we are working, we are taking the decision, keeping in mind directly, indirectly as a optimization. Always we have gone for to maximize our efficiency or productivity. तो जनरली इसमें हमारा अटेम्प्ट, हमारा डिसीजन मेकिंग का जो अटेम्प्ट रहता है वो है मिनिमम से मिनिमम रिसोर्स यूज करके मैक्सिमम से मैक्सिमम बेनिफिट लिया जाए. That is the optimization, and therefore in the AIs in the emerging areas, the role of optimization will increase, will enhance in the future. Therefore, it is a. I hope and I am very confident that this optimization method will have a very long impact in the near future, 10 to 20 years, when these emerging areas will have the fully work in the industries and in the administration. With this, I welcome all you in this inaugural part of this STTP, ACT sponsored STTP in optimization method, and I hope and I request all participants kindly go through this all sessions sincerely, because at the same time we have to note the attendance also, and we have to send it to the AICT also. Definitely, I think with an very good sincere effort, if we go for this optimization method, this will be very useful also in our research work, particularly those who are inspired for aspirant of the PhD work. So this optimization method can be used to address their problems, their topics I think it will be a very good and hopeful, very means fruitful for all the participants. With this, once again, I am thankful and grateful to all resource person, and particularly thank to our organizing committee who has been continuous busy with organizing this. Because of as an administrator post as a director, I have some limited time. Therefore, they are doing a very great job. Thanks to them, and at the same time, I am also thanks to all participants. Once again, best wishes. Thank you. Thank you very much.
Thank you so much, sir. We assure you that your guidance will help us to gear towards better future. Dear participants, with this we are done with the inaugural ceremony, and with the hope that we will all have one week of interesting and interactive learning. Let us start with the session. But before we start the session, I would like to give a brief introduction to our speaker, Dr. Arshad Javed. Dear participants, Dr. Arshad Javed is presently associated with Department of Mechanical Engineering, BITS Pilani, Hyderabad campus. He received his PhD in Mechanical Engineering Topology Optimization from BITS Pilani in the year 2014. He completed his Master of Engineering in Mechanical Engineering from BITS Pilani campus in 2008. He received his Bachelor of Technology in Mechanical Engineering from Bundelkhand Institute of Engineering and Technology, Jhansi, Uttar Pradesh in the year 2004. Before being associated with BITS Pilani Hyderabad campus, he was also associated as lecturer in Caledonian College of Engineering, Oman, which is affiliated to Glasgow Caledonian University, Scotland, United Kingdom. He was also associated as lecturer in BITS Pilani campus from 2009 to 2014. His major area of research interest include topology optimization, compliant mechanism, micromechanism, robotic and automation system, mechatronic system, automation of microfluidic system, etc. He has delivered various expert lectures on topics like nanorobotics, recent advances in design and development of mechatronics and robotic system, etc. He has more than 50 publications in various reputed journals and national and international conference. We are glad to have as our speaker, sir. Now I request you to start with your session. Dr. Arshad Javed, sir, please.
Yeah, thank you very much. I'm glad to join this particular session, and I'm thankful to the organizer team, the director, and the organizers. And dear past participants, let us start today's session. So let me share the screen. I think it is. So I hope now you can see the screen, isn't it? Is the screen visible to all? The slides
Yes,
have been.
sir.
Yeah. So let us directly come on to the topic. So this is the first session, and I'm fortunate to have the first session in this good program. And the topic of this session is basics of statistics for engineering applications. And this is going to be the basic, you can say the basic fundamental which is going to work towards all the sessions in this particular training program. So first of all, let us see what is statistics and why we need to know the fundamentals of statistics. So as the bookish definition which is given in front of you says that it is a branch of mathematics, correct? So it is a branch of mathematics that consists of methods of processing and analyzing the data to better support rational decision making process. Now let us understand this definition. So as it says that it is a branch of mathematics. Now in the present era there is no boundary among any branch of engineering and science. Everybody is working towards all the different branches of engineering and sciences, because we are somehow we are forced to develop products and make the improvement in products and processes. So when you talk about any product is always multidisciplinary product, in which not only engineering but sciences concepts are also involved. So if one has to develop the product, one has to understand the product, one has to improve the product, and further if they wanted to do the optimization on some kind of improvement in the product, we need to understand the governing equations, and we need to understand how this product is working and how can we improve further the product functioning. So that is why we need to jump in different areas of engineering and sciences. So nowadays mathematics works as a basic tool for any engineering application, and that is why we need to go into this one. And then what is the role here? You can see there are two main things which are reported in the definition. First one is method of processing. How to process, method of processing and analyzing the data. So it says that we must have something called as data. Okay, we must have a data structure or some data. And then we need to know how to process the data and how to understand this data. That what is the physical inferences from this data and how can we get the importance feature from this data. That science is nothing but statistics. And hello, can you hear me? Hello, can you hear me?
Yes, sir, we can hear you, sir.
So if you cannot hear me or if there is any problem in display, please let me know so that I can see other things. Now these are the two things which are very important to statistics, and what it helps to understand the process. And once you understand the process, you know how each parameter is affecting, how to drive this process towards the optimization or towards the desired domain of application. So until you have analyzed the data, you can say that you are sitting in a vehicle and the vehicle is moving randomly and you don't really have any control over that. And it takes here and there. Yeah, the vehicle takes you here and there. The moment you realize that this is steering and there is something brake, there is something accelerator and so on, you can drive this vehicle in the way you want and you can move this vehicle to the area you wanted to take it. So that is what is statistics. We have a data car here, okay, and we wanted to go to a particular goal here, and we need to understand where is the steering, where are the controls of this data that will help us to drive this data or drive the system towards the required goal. So that is the basics of the statistics. Now this is largely related to another field of mathematics, which is called as probability income. So I think other can mute themselves so that other participants can mute their microphones. Now coming to the importance of statistics, why should we study or why an engineer should study statistics?
Sir, you are muted.
Hello, can you hear me? Hello.
Yes, sir, continue.
Actually, it is saying that someone in the meeting muted you. So I think in the process of unmuting all, I was also muted. My video is coming to you? No.
Yes, coming.
Okay, fine. Share screen is also coming. Fine. So we were talking about the real world and the theoretical world. This is very important to understand. This slide is very important to understand because the methods and processes that are following these all topics are very common recipes actually of mathematics. statistics, but we have to understand what and how we can employ. Participants can mute themselves. It is creating noise. Yeah. So importance of statistics in engineering application. That is what we were discussing, and we talked about real world versus theoretical world. So let us take a metallic bar made of mild steel. The yield stress may be somewhere. Let us assume 150 megapascal, and ultimate stress is 200 gigapascal. Let us say, and then we try to find out the stress from this one. So stress is equal E is equal to stress by strain, and stress is equal to Young's modulus of velocity into strain. When we take a piece of metal and then we make a rod and we try to stretch in both directions, we know the force, we know the area. How can we calculate the stress out of this one? So we know this formulation, and we know force by area also. So let us say that you have computed the stress value, and now you wanted to compute the strain. So strain is equal to by E, and sigma value get F by A and E. This E is a theoretical value. This is a theoretical value obtained from data table or data sheet. This is what we plug here. F and A is the real value. It is the real world value. While E value is a theoretical value, or you can say experimental value, which is coming from data sheet. Now it is written that E is, let us say, if you take the yield stress 150 megapascal, if you wanted to know with respect to this yielding only. So there is no guarantee that this value of sigma y will be 150. It will be having some plus minus values. Let us say plus minus 10% value. It means it can be 150 plus 0.1 into 150, or 150 minus 0.1 into 150, or between anything, between these two ranges. So the E value can be anywhere between these two values. Hence our
ನೀನ್ ಬರೀ ಮಾತಾಡ್ತಾರಮ್ಮ ನಡಿಯಮ್ಮ ಕುದ್ರು.
process of muting all. This may be muting mine also. Now I have made it unmute. Let us see. So we talked about that in the real world, the values are probabilistic in nature, okay, and the output which we compute here is also a probabilistic value. Unlike the theoretical world where you compute the strain value, which is a single value, The real world will give you a strain value having some tolerance value, or more specifically, when you say that it is going to be varied within a particular range, it means you are going to define a probabilistic value, and then the strain values will be varying probabilistically within a particular range, which is shown here. So this is the problem here. And what are we doing here? If you take all the values of elasticity and compute all the possible values of epsilon to a infinite sample size or very large number of steel rod, taking one by one each, and every steel rod employing the same load, and calculating the strain value experimentally, we can plot it and see that it's giving a distribution which is normally known as normal or Gaussian distribution. And then you will find that any experiment we perform is a single point from this distribution, and this is a probabilistic value. There is a probability involved with this one. So that's what is coming here, which is real world versus theoretical world. The real world is always deterministic. We use this term, deterministic, while the real world is always probabilistic, while the theoretical world is always deterministic. So while engineers or the practitioners need to go to the theoretical world, they need to see that they consider the values of probability, values of probable variations within the constants and within the parameters, so that they get the values near to the experimental values. Now here, what is involved, how human beings work earlier to this development of mathematics. We use our natural intelligence, use our skill and experience to judge where the failure will take place, how the failure takes place. And when you say intelligence and experience, it requires large number of data training. For example, there is a skilled worker who is working in a machining shop, and he observes that how the things are going to be failed one by one. He will be able to tell you that if you machine it like this, this machining is going to be failed, because the worker has gone through multiple data set, and he or she understood that if the worker is having experience of, let us say, 10 years on lathe machine, he will be very well understanding that how the surface finish is going to come when you have different values of variable input factors. So what actually happens here? His human intelligence and experience works better to make him understand what is the process mean, what is standard deviation, and so on. So we don't name these parameters by their mathematical terminologies, but experience and intelligence gives human being is, you can say, inherent statistics to understand the data based on their experience. Now, if we have to implant the same intelligence and experience in machines, what we need to do? Can we arrange a human brain and fit in a computer? Is it possible? Or fit it in a lathe machine so that the lathe machine automatically adjusts its surface finish parameters and give you whatever is required. So we found that it is not possible. Human brain and understanding cannot be implanted directly to any machine or computer, and still people are doing it, and known as AI. So how to do this? So we have to find out the alternate methodologies which are doing the similar task which is done by human brain. So that is what is the emergence of different mathematical area, and one of the processes statistics, which is going to work about this experience and learning. So is experience and learning, experience and learning. Now let us come to the basic terminologies. First one is population, sample, parameter, statistic, and variable. Okay. So what is population? If you take all the possible data, that is called as population. Let us go back to our this world, where we have taken a steel rod and measured the value of strain. You applied the stress and measure the value of strain. Now, if you have a big block from which you are taking the steel rod, we create n number of steel rods using this. All n number of rods you test it. So, say we generate 120 rods.
ಇಂಗ್ಲಿಷ್ ಮೀಡಿಯಂ ಅಲ್ಲ ಇವತ್ತು ನೋಡ ಏನೆಲ್ಲ
you get n number of rods here. Now, what the experience which we do in the lab with us or experimentally, we use 2 rods or we use 3 rods here for some experimental work or some product development tasks. So we use 3 rod only from this block, and then see that different strains are coming here. While actually from this whole block we can generate 120 rods. So 120 becomes the overall population, and 3 rods which you are using in the real life become the sample, probabilistic sample. You just choose 2 rods and use it. From the whole bunch of manufactured batch, we use 2, 3, 4, 5. So this is called as sample. And in the other way, we say that all members of a group about which you want to draw the conclusion is called as population, and part of population selected for analysis is sample. This is another way to look into the problem. This is another way, it's a mathematical way to look into the problem. And what we defined here is the engineering way to look into the problem. When we use 1 or 2 or 3 similar product, it becomes a sample, correct? And when you talk about the whole production line which produces lakhs of that component or product, is become the whole population of the batch size. Now coming to another parameter, another thing, terminology which is called as parameter. So it's a numerical measure of a single property of that population. So the manufacturer, when it sells or gives a particular rod to you, it says that the manufacturer data sheet says that the elasticity value will be 150 megapascal plus minus 10% variation, plus minus 10% variation. So this is average value. 150 megapascal is average value. So it gives you the rod with an average value is 150 megapascal. So this is a single parameter, and which is calculated based on the whole lot of the production. That is called as parameter. It may be average, it may be a variation value, and so on. We'll see later. So it is a parameter which is based on the whole population. Now coming to statistic. Statistic is also a parameter, but it is based on sample. It is not based on parameter, but it is based on sample only. Then coming to variable, the characteristic of an individual item or individual that will be analyzed using statistics. So this is called as a variable. A characteristic of a single parameter is called as variable. So let us see few items which are given here, and let us see if you can answer through chat box. Let me see the chat box here. So participants are there. So try to answer this if you understood this.
ಒಂದು ಚಾರ್ಟರ್ ತೋರ್ಸಂತಮ್ಮ 7 days ಅದು ಇವತ್ತು ಸ್ಟಾರ್ಟ್ ಆಗೈತೆ ನೋಡಿ. ಈಗ ವೆಲ್ಕಮ್ ಆಯ್ತು, ಈಗ ಇನಾಗ್ರಲ್ ಫಂಕ್ಷನ್ ಆಗಿ ವೆಲ್ಕಮ್ ಆಗೈತೆ.
So what one is the variable defining the test and single data set. So what do we call this as? The variables defining the taste and taste of chocolate. What is this? Population, sample, parameter, statistic, or variable. So this is a variable which is defining the taste. So it will become under the 5th category, which is variable. Similarly, 100 boxes of chocolate selected from a factory's production line. So factory is producing lakhs of chocolate per day, and we have selected 100 samples from there, 100 boxes from there. So what is this classified as? Can you answer, dear participants? Sample. So this will be a sample, second number. Then the average weight of a sample of chocolate boxes produced on a factory's production line on the particular day. So company has produced lakhs of chocolate, we have taken a sample, and then you find out what is the average weight of this box. So this will be a static. Okay, here it is a variable or data associated, a parameter associated with the sample itself. So it is called a statistic. Okay, this is a particular data associated with sample. This black one is fourth point. It is statistic. Then the average weight of all the chocolates boxes produced on the factory production on a particular day. So it is the whole lot of chocolate which is produced here. So what will it be? Is it population? Yeah. So it is going to be parameter which is about the whole lot, and then it is not about the sample. And the last one is the entire daily output of a chocolate factory, let us say production line. So it will be entire production is population. So now you understood these all parameters. We'll move ahead with the concept of probability. You all know it already, but let us quickly brush it and move ahead. And I'm looking towards time also. We have to finish it on the time. So I'll be little fast. So what is probability? You know it very well. When the event happens, certain event happen, we say that the probability is 1, certainly happening. And when the event is not happening, we define it as 0. And the probability is defined as number of occurrence of that event, the favorable event, divided by total number of possibilities or total number of things which are there. We'll see with a quick example. So it is produced that it is said that a company makes plastic storage bag for food industry. Out of the hourly production of 2,500 gram bags, 2,500 gram bag, 40 were found to be non-conforming. So what is the probability that being it is non-conforming? So out of 2,000, 40 were not conforming. The population size is 2,000. Total population size is 2,000, and 40 is the event of non-conforming. So what is the probability if someone checks this lot and found a non-conforming? So the event is the event which happens 40 times, and total number of occurrence of that event or total number of possibility is 2,000. So the probability is equal to 40 by 2,000. This is very simple and you all know this, so we'll not emphasize much more here and move ahead. Let us talk about simple and compound events. What is simple event and what is compound event? Simple event is the least amount of cell of event that can be classified. They represent the most elementary form of the outcome in the possible experiment. So this is the, you can say, one cell of the event. And compound is multiples of this simple event. So compound event can be broken into different simple events, but the simple event cannot be broken further. That we have to understand. Now let us see one example and it will be more clear to us. Suppose that an inspector is sampling the transistors from an assembly line and identifying them as acceptable or not. I am reading the question. Please look into this. Suppose the inspector choose 2 transistors. Okay. So in the assembly line, different transistors are being manufactured. It is moving on, let us say, on conveyor. And the person who checks the quality of this transistor, he picks 2 out from here, 1 and 2. What are the simple events? What will happen actually? What are the different events that will happen? Give an example of compound event. What are the simple events and what are the compound events in this one? And find the probability of finding at least one acceptable transistor. So 3 questions are involved here. Let us see one by one. So simple events are these. These are the simple event. Event number A1, that the first transistor is acceptable, is okay. Event number D1, that the first transistor is not acceptable. Similarly, A2, A1, and the second transistor is good and second transistor is not good. So there are 4, you can say, different or discrete events are combined here. Then one of the compound event can be, so this is the set of possibility. Both which are picked, both are good. Okay. Then we pick both are not working. Sample, these are the 2 transistor number 1 is working, 2 is not working, and 1 is not working, 2 is working. So there are 4 compound events which can be created here. So these are the 4 compound events which can be created here. And simple event is these all. So now we have to find out the probability at least one of the transistor is acceptable. So at least one is acceptable from this table. This is also called as truth table, but we don't go into this one. So let us say transistor 1 and transistor 2. It is working, both are working. This is working, it is not working. This is not working, it is working, and both are not working. So total number of events are how many? There are total 4 events, out of which at least one of the transistor is acceptable. Is how many? This is the event in which at least one is working. At least one is working. In this, at least one is working. In this, at least one is working. So there are 3 events in which at least one are working, and there are total 4 events. So the probability of B that at least one is working is 3/4. Okay, so there is a large. And what is the probability that no one is working? Probability that, let us say, another event C in which none of the transistor is working. So you can see that there is only one event in which both are not working. So it is 1/4. What is the event in which both are working? So it is also 1/4. What is the event in which only one transistor is working? Is how much? It is P of, let us say, event D, only one is working, is 2/4, because this is 2 and total are 4. So like that you can see, we can see the example of simple event and compound event. Let us go a little bit more into this one. There are few slides only on probability. The component of an, this also we know the complementary or the component of A. So if A is happening, it is A, and what is the probability A does not happen is 1 minus probability of A. And this is written as complementary of A. So if you say that, same example, what is the event that none of the transistor picked are not working? So it will be 1 minus PB. So it is 1 minus 3/4, which is 1/4, which is equal to this one when none of the transistors are working. So this is how the complementary is found. The favorable event is 1 minus the favorable event is the opposite event. Okay. Now let us say this example we have seen just now. Coming to 2 laws, additive law and multiplicable law. So in additive law, probability defines the union of 2 event. Actually, in book they make this kind of figure, which is not the correct representation. The figure may be like this one. This is the whole sample of event, in which there are 2 possibility, 1 occurs and 2 occur, event number A and event number B. So this event, these are the 2 possibility. Event A is this one, and the boundary of event B comes like this. The boundary of B like this. So this thick line is the boundary of B, let us say, and this thin line is boundary of event A. So thick line is boundary of B and thin line is. So in this experiment, either A will take place or B will take place. You let us say the example that you put a rod for in a loading condition. The rod gets broken and rod gets necking. Necking, you understand, like just expand in the length with yielding. So when you apply a load to this one, so 2 things may happen. One is broken and another one is necking. Or there is a compound event where both happens. It breaks with necking. So you can see that this is the set of event. Either B happens or A happens or both get happens. So what is the probability that both get happens is the union of both probability of A and probability of B, and you can see this area where both are common, which is added in both P and PP, that we have to remove because already it is added together. So minus P intersection U. So this is this shaded region which we are intersecting because it is already included in B and A. So that is how, when you wanted to add the probability of two events, we need to subtract once which is common because it is already included in PA and PB. Now coming to multiplicative law, what it says that it is the probability that defines the probability of intersection of two or more events. So we wanted to know in this problem that what is the probability that the rod breaks with necking. Okay, rod break with necking, not only necking and not only breaking, but the both phenomena is observed. So it is intersection here, this shaded area you wanted to know. So how to compute this shaded area? Fine. So in this case, what we will do, PA and PB both happens. We say that probability that breakage happens and probability that necking happens, and both happen together. You can see and logic is involved here, A and B. So we represent it in this way: PA, A happens and B happens provided that A is also happening. Event B is occurring provided that A is also occurring. So this will give you the intersection, or in other words, you can say the probability that A is occurring and B is occurring and A is occurring provided that B is also occurring. It is very simple to understand. Let us see it in words, because these mathematical things need to be understood very well in common sense also. Let us say this is the domain of A and this is the domain of B. So I have to make it exactly overlapping. Nothing has to be left from here. So B will not be starting from here. So I will take B from here. So these are the 2 points. This thick one is B and thin is A. This is event B and this is event A. A is this one. So when you say that you wanted to find out this shaded region, so what will happen? We will say that what is the chances, what is the probability, and what are the number of possible cases in which A happens, okay, this total, and in which B also happens provided they A also happens. It means you are directly inferring to this particular region only. So this gives you this particular shaded area, which is the probability of A intersection B, or it means both event happens together. So we have to multiply this. Now, if the event is totally independent event, like A and B does not happen together at all, this shaded region is 0, then what will happen? So it becomes this kind of distribution of total number of event. A is here and B is here. There is no interaction among A and B. So what we need to do, there is no overlap. No overlap. Both events happen independently. Then in this case, B given A is B only and A given B is A only. Both can happen independent of each other, not dependent to each other. It means the happening of B is not going to be dependent on A. Like you can get B as well as you can get A. So it means, let us say there are two in probability, people take coin example. So let's take the coin example. There are 2 coins we have taken, and number of head and tail in these 2 coins are independent to each other. This is head and this is tail. If you take one coin, let us see, if you take one coin, the head and tail event is going to be attached together. If you get head on the top, it means you will never get tail on the top. Both cannot happen simultaneously, so it is going to be dependent. But if you take 2 coins and you get head here, it is not going to say that you can't get head here because you get head here. So if you get head here, you may get tail here also, or you may get head here also. So both are not going to be affecting each other. If you just make a toss with one coin, you may get head or tail. In other coin also you may get head or tail. So both activities are independent. If you wanted to know what is the probability that I get head in both coins, then I need to multiply these probability of heads in both coin together to know what is the probability that in one set of condition I get head in both coins. So I have to multiply these two individually. The probability of one to other one has to be multiplied, and this will also work fine, because if A happens, provided that B happens, provided that A happens is equal to B only, because there is all possibility that you get head here, provided that something happens here. So it is all about B, and similarly it is all about A. Now coming to mutually exclusive event, that cannot happen simultaneously, as we have taken the example of the head and tail. So here it will be added together, which cannot happen simultaneously. So let us take one example and quickly move. I think I should skip the example and move. It is 12:30. So let us move towards the statistical part. Now coming to statistics, these are some example which the slide will be probably given. So you can see these examples. Study material and objective questions are also given, so you can do the practice. So now coming to statistics, there are two types of statistics. One is called as descriptive, other one is called as inferential. What are these two? Descriptives talk about whole lot of points, or talk about the whole population, correct? Suppose let us take this workshop itself, and let us say there are 100 participants, and you wanted to know let us say and you have circulated a feedback form, let us say feedback form, in which the points are 1 to 5, satisfactory to non-satisfactory. 1 is fully satisfied and 5 is not satisfied. 1, 2, 3, 4, 5. And each participant gives you a particular number. 1, 2, 4, 5, and like that. So all 100 participants will give you a number, which is going to give you the feedback point, a single point. Now you wanted to know what is the average satisfactory level from all the 100 participants. So you will find out the average, and you may get, let us say, 1.5, very near to the satisfactory point. So this is about the whole lot of points, and you get 1.5 average. It means the conference was successful, the workshop was successful, and everybody was satisfied. And then you do another thing. Suppose on the larger scale, next year you again have this workshop with 10,000 participants across India, and then you have conducted the feedback survey, same survey, and 1 to 5 points were given. But somehow we were not able to bring all the data on one table to analyze. We could not do it because of some issue. Some participant did not provide the feedback. Some participants' feedback were lost. Mail did not receive. Mail bounced, or something happens. So out of 1,000, we could not get all data, but we could only analyze a set of 100 data. Okay, and here we said the average was 1.0 for set of 100 feedback only. The average was 100. So here it will be called as inferential statistic, where we try to, now looking at this data, we may say something about this 10,000. Since we get average here as 1 for 100 participant, not for 10,000, we may say ki theek hai, it may be, if for 100 it is 1, for 10,000 worst it may be 2. Okay, and 1 is the final limit. So 2 to 1 may be the final thing. So we are going to bring an inference, a prediction, a forecasting from the data of sample. So when we analyze a sample, we get some value, and which may not be the true representative of the whole lot, but may be true up to a certain extent. So this kind of a statistic is called as inferential statistic. And when we collect all the 10,000 data and find out the real average of that one, that is called as descriptive statistics. Now my question to you is, in the real engineering example, as we have taken earlier, which kind of statistics is used, descriptive or inferential? Let us say that you bought a nail from a manufacturer, and when you are nailing, it gets bent most of the time. So how many nails get bent at the time, you wanted to know. So, and then you can classify it as good nail or bad nail. So such kind of experiment, if you conduct in real time, what type of statistic it will be, descriptive or inferential? Please answer in chat box. Unable to hear? Yeah, you can hear. Yeah. What kind of statistic it will be, descriptive or inferential? So here you can see that in engineering applications, we don't have a whole bunch of produced like nail or any kind of parts which a company has produced. We only use a bunch of data, bunch of sample only to use. We only use one sample, one box of nail, which we might have taken from a company or batch, and then we test it and found broken, not broken, bend, not bend, and so on. So this is going to be inferential statistics always, and it is largely going to be dependent on probability and other concepts. Descriptive will be maybe done by the manufacturer who is producing the whole lot. This is also called, comes in 100% testing. This 100% testing of the equipment. And inferential will be done by the user who will buy 4 or 5, like you buy something from a company, and you bought first one, it failed, second one it failed, third one you bought, it is also failed. So you say all the items from this company is fail only. Or you bought one successful, second failed, third also successful. You can say my review, like a review star, you can say you can give some star 4.3.5 or so on. Here 0 out of 5 and so on. So you grade the whole manufacturing company as bad or fail always if you get a sample of 3 and all fail. So you say the whole lot is waste, you don't get anything. But if you bought 3 products out of that and all worked successfully, so you said this company is very good and it is producing very good. But this company may be producing thousands and lakhs of product per day, but you have tested only 3 and you classified this company is good. So this is going to be called as inferential statistics. You have experienced this 3 times and you found all the 3 times it was good, so you took it as good and granted. But all the 3 times it is bad, so you stamp it as a bad company and bad review. So this comes in inferential statistics, where we take the inference, we take the prediction and move ahead we talk about the whole population based on the sample size. So in real time, if we see, inferential statistics is the one which is largely utilized and which brings probability and intelligence. Like people are collecting sample from the surface of moon. So we cannot bring the whole moon on the earth. We can bring only the sample. Based on sample, we may predict that this is how the environment on the moon surface may be. This is how the particles of elements present on the moon. But it may not be true, or which may be 100% true. So most of the time in engineering application, we employ inferential statistics compared to descriptive statistics. So let us see a few more things. Data collection and variables. These are very simple example. I'll quickly go through that. One data is direct observation, another one is the indirect observation. Indirect observation and indirect observation, as the definition says, that measurement of quality characteristic taken by observer directly. Indirect, the data is not observed by the experimenter and then it is provided by somebody else, like the feedback as we have discussed, or you directly go to the person and ask the feedback. That is another thing. So what is the difference between this one? The key point is non-controllable factors. Non-controllable factors. So when the direct observation is there, the error will be less. Error will be less. Environmental or non-controllable factor will not be involved in that. But when you go for indirect observation, there may be infinite type of region which may bring a failure situation. Correct? We send a mail from one person to another person. The email cannot reach to this person based on hundreds of excuses and hundreds of reasons. The servers were down, internet was not connected, my computer is not working, your computer is not working, and so on. There are hundreds of reasons through which an email cannot be properly sent from one person to another person. So this is called as non-controllable factor, environmental factor, or error. So in the direct observation, you go to this person and ask the thing which you want to ask. So there is no email involved here. So there is no error caused by the email is involved here. So this is the difference between direct observation and indirect observation. And that factor is called as random variable, which is bringing the error into this one. Now this random variable can be continuous or discrete. That we know very well. So continuous means the value change in decimal 1, 1.1, 1.2, and so on. Discrete means you get colors, dark color, light color, blue, red, and so on. So it is discrete, and the other one is random. Now coming to other point, accuracy and precision, you know it very well. But what you need to know here is very important. What do you see here? This is the accurate point, and the data value is around here. And here is the accurate point 5.25, and data is scattered to other side. So what we say here, we say that it is accurate and somewhat precise. This is precise but not accurate. That's what we say. And suppose if you get another curve where all this is the accuracy point, and you get all the data collected here nearby compared to this one. So you can say that this is accurate and this is precise also. This is, you can say, accurate but not precise because data has moved away from this one. So we know it already, but what we need to know here mathematically, this line, precision precision is the degree of variability of observation. So is a degree of precision is actually is left here is a degree of variability in the observation. So here you can see variability means this spread is less, this spread is large, and here this spread is less. So when you say it is precise, it means any time when you check it, it is going to be very near value compared to the previous one. Correct. So precise means whenever you take the data observation, you get very close to the previous data. So all the data are collected together. It means it's a precise data. Every time you get the similar reading. It may be accurate, it may not be accurate, but the machine is giving always a precise. So the variability is less. And large variability means if any time when you take the reading, it will be here and there compared to the previous one. It means the variability is larger. Now coming to different measurement scale, this is also very obvious. Nominal scale, where you have numbers which are given here. Ordinal scale means you say grade A plus, A minus, okay, B plus, B minus. So you can put in ordinal. Interval scale, like you have weight of something, let us say 1 kg, 1.2 kg, 1.4 kg in arithmetic mean, let us say in arithmetic progression 1.6. So you can see there is a particular interval which is followed here. Ratio scale, in which it is a ratio like 1 kg weight, then 1.2, 1.4. So this we can compare 1.4 compared to 1 is 40% larger, like this. So here you can compare with any of the reading in terms of the ratio also. So this is different type of scale which is normally used in different type of experiments. Now coming to, slowly we are growing into the mathematical part of the statistics. It is 12:41, so I'll be little fast. Measure of central tendency. What is central tendency, and what are the measures? How do we evaluate it? So there are something. First thing is called as mean. So when you take out of 10,000 total population, when you take only 100 sample and you wanted to find out the average, it is called as sample mean, because you are playing with sample. You don't have the whole lot. Playing with sample only, found out average, total divided by number of sample value, okay, n, which is 100 here. And then population mean means you talk about all 10,000 here and find out the average. This is represented by mu, and it is called as population mean. Formula is same. Coming to median, this is also very simple. Median is the stepped value in when the observations are ranked 1, 2, 3, 4. So let us see the example. There are different piston ring diameter values. These all are given. So in order to find out the median, what we do, we arrange in ascending or descending order, 1, 2, 3, 4, 5, and so on. And whichever data number is at the center is called as the median. Till now, this is what we have done in up to class 10th and 12th. You may be thinking, why are we studying? We know this median, and mode will also come. But there is an importance here. So you can see that the middle one is, there are 1, 2, 3, 4, 5 data here. 5 data here. Middle is between 5, this one, 52.3 to 52.4. So average, you can take both of that and you can say that the median is 52.35. The median is this 52.35. Now it may be different from mean also. It may be very much different from mean. What is the role here? This example is very important, which will tell you what is the meaning of, or what is the value of median and mean, and how is it different from others. So actually, coming out from this topic, I wanted to ask you one thing. Have you heard of the term robust? At least you say yes or no. There is a machinery here. This is a machine. Let us take, there is a machine here in which you put the raw material, some pieces here, you put raw material here, and you get powder of these metal blocks. You get out of this the powder of these metal blocks. It is a crushing machine, you get a powder here. And then you measure the grain size, grain or particle size of this. So we have a particle size which is a response. Particle size is called as a response. This is the response, this is the outcome here. What is the uncertainty? The uncertainty is you are supposed to always give a mild steel pieces here, not any other steel here, mild steel here. But there is a 10% chance that out of 100 small chunks, 10 chunk may be not mild steel. This is 10 chunk is not MS. So this is now going to termed as uncertainty. 10% uncertainty is there, means 90% mild steel is sure, pakka hai. 90% you will have a mild steel. But there are 10% chance that you may get mild steel within 10% or you may get zero mild steel within 10%. So this is uncertainty. You are going to, when you put different material here, you are going to get different grain size because machinery parameters are fixed. Okay, this is the only input parameter. This is input, and response is grain size output. So here let us say 1 mm you get for mild steel. For aluminum you get 0.8 mm. For cast iron you get 1.5 mm, and so on. So when you mix different kind of element together, you may not get the exact response. But this machine will be robust if even we add 10% of different material, the grain size is going to be unchanged. Even if you mix 10% mild steel, slightly, not 100%, 10% mild steel, cast iron, whatever you add together, you are not going to deviate from the output, even though the uncertainties are involved. This is called as a robust system. So the definition of the robust system is the output is not going to be changed, even if the uncertainties are involved in input. Correct? In more bookish way, the response is insensitive to the uncertainty. It is not sensing it. There is no difference. There is no change in the output means insensitive to the uncertainties, and this system is called as robust. So for robust system, mean is not a correct measure. The correct measure is median. Why? Suppose something happened, they have taken 10 sample, random sample of piston ring diameter. Something happened in measurement, and here you have involved an uncertainty. You involved uncertainty. Instead of 51.9, you measured it wrongly 41.9. The operator was not in good mood. He had a fight with the manager. So he voluntarily wrote it 41.9 in the data sheet. Now you tell me, if you calculate the average or the mean of this sample, and instead of 51.9, the uncertain parameter 41.9 is taken, the mean will be changed. Mean will be changed, and the manager will understand. It will obviously go down below 52 point this one, and it will get 48.23, let us say. So the manager will understand, okay, there is some problem in the process, something is happening wrong, or I need to change the machinery and so on, because the manager is looking towards the wrong data. If you instead of mean would have taken median, so the 10 measurement is brought to the manager, who has to take decision about buying a new machinery for surface finish offering. The mean is not going to be changed here. Median is not going to be changed here, because whatever you put here in place of 51.9, it will only check which data is lying on the center. So until we have a change in 52.3 and 42.4, these extreme data are not going to make any change in the numerical value of the median. It is not going to be changed. So the manager will not take any drastic decision based on one uncertainty involved in one data. And it is obvious. It is obvious. When we conduct experiments, some experiment may happen in a wrong way, but that wrong way may not indicate that the product was wrong. The process was wrong. That is why the 41.9 has taken into account. But the piston ring was correct. It was 51.9 only. So these type of uncertainties should not be taken in the inferences. So that is why in most of the cases, median is preferred over the mean. Now there is this example. If you see later, you will be able to understand here. Now there is something is called as outliers. Outliers means some data will be sparse away. Just now we talk about 51.2. Instead of that, you write 41.9. Correct. So outliers. So if you take mean is going to vary from here to here. If you bring your outlier here, the mean is going to come here, which will give you a wrong representation of the data. This is a specific condition. This is a specific condition which has brought this data to very far away, but it does not. This mean does not say that your all things are going to be covered. Let us take an example of students' weight in a class. So let us say there is a nursery school in which, in particular class, 30 students are there, and a health worker comes and asks, "What is the average data of your class?" Okay, what is the average data of weight of students in the class? And we measure, for let us say nursery class, it is let us say 20 kg. 20.0 kg is the weight. It is okay, fine. All students are healthy and well. Now what happens? There is a student who keeps on sitting in the class randomly, and who sat here. He was class 5th student, weighing 40 kg. Weighing 40 kg, also sat in the class. Now the whole average is going to be shifted from 20 towards, let us say, 25. So the health worker will say, "Oh, your class average is very high for 30 students. It means there is something wrong. All students are taking extra meal and not walking, jumping, no physical exercise. So obesity is observed." You will write an inference. Obesity is observed in particular class. But this is a wrong data. This is a wrong information. This has happened because one outlier is also sitting here. Or by mistake, we have measured the weight of class teacher also. Correct. So this is the wrong data. So for wrong data, you can see the whole mean has shifted from exact mean actual value to another value. So mean is going to be changed. So that is why we need to put the median here. So you put teacher weight, let us say, or student weight 40, then 20.1, 19.2, 20.2, and so on. And you said where is the central data, and you find out this is going to be the median. So rank wise we put here, and the central rank is considered. This is more, median is called as the central rank, you can say. So the central rank will tell that this is how it is there, and this median is not going to be affected by outlier. And median, now this is very important, median is more robust compared to mean. So in such process where this kind of things are involved, we take median compared to mean. Okay, now move ahead. There is example, will not go with example. For each concept I have taken different example. Now coming to the range and all, this is also very simple. So range is just lower value and upper value, and we find out the range. Like these are the data, you can find out the range, the max and min. Maximum is this one, minimum is this one, and you can find out the range. So that is simple. Now coming to the variance. What is variance? So variance is the degree of variability within the data, how much they are away from each other. So pictorially you can show it that one person weight is here, another person weight is here, another person's weight is here, and so you can see degree of variability. In other way, if you make another observation and you see that one person's weight here, another is here, another weight is here, another weight is here. So for the 4-person, you can see different weights, and you can see similar weights. So in normal observation, like you go to a cloth shop and you ask, show me the jeans, show 1 jeans, 2 jeans, 3 jeans, and say that's all. Then you go to other shop, give you 1, 2, 3, 4, 5 number of jeans in different sizes and different colors. So you say that large variety is available here. That's what we use there. Large variety is available here. Large variety. And you say koi bhi variety nahi. There is no less variety. No variety is less variety. So it is about variability. So this data is having larger variance or variability, and this data is having less variance or variability. So numerically, how do we find out? We find out the mean of this one, mu or x for sample, mu for population, and then each point is going to be computed with respect to this mean, that how much it is far from this one, how much this is far, how much this is far from the mean, and how much this is far. Then square of that and divided by total number of data, which is 4 here. So that is going to be given as the variance value, sigma square. Sigma is standard deviation, right? Standard deviation. So when you square it, it becomes the variance, and the unit will be square. That is also there. And for sample, it is represented as s square, and the same formulation will be used. Now you can see that one observation. When you take the whole population, you have divided by n, and when you take a small sample, we have divided by n minus. This is a very important point, which will come in when you study the confidence interval. I don't know whether it will be able to complete or not. So next 10 minutes, I will close the session. So when you take the whole population, it is n, and when you take a sample, it is n minus 1. Why it is n minus 1? What is the reason? The reason is when you take the different samples here, different, let us understand it in a proper way. When you take a different sample, let us take a factory example where 10,000 parts are produced. Let us say nut bolts, 10,000 nut bolts are produced here. This is a batch of 10,000. You wanted to know what is the surface finish of thread of each. So you have taken 10 nut bolt randomly here. So this 10 is called a sample. This is sample. And this is what? What is this? This is whole population. Now you have taken this one and find out mean, which is x, and found out variance s square. In this also there is a mean, mu, and in this there is a variance which is sigma square. Now you tell me one thing, this sigma square and S square, should it be same or not? When you take different sample, multiple samples, and when this number is closer to this one, this becomes equal to each other. This becomes equal to each other. But here itself, in this formulation, which we have just now seen, mathematically derivations I have omitted here for quick understanding. If you take n here, capital N here, small n here, instead of, because sample size is small n, so instead of small n, we have taken n minus 1. So if you take n here, for different samples, if you add it together, this is not coming to sigma square. And when we take it as n minus 1, this is going to be equal to each other. This is shown here. Number of occurrence, sample variance. So different samples are there. Let us say these all blocks are different sample blocks. And for each sample, you calculate S square. Okay, and then average of this S, the expected value of average of this S is going to be equal to sigma square. That happens only when you bring here. So that is n minus 1 is brought here, and this is also called as degree of. So, and this is called as property of unbiasedness. It means unbiasedness means when we add average of all the variances of all the sample size, it should be equal to sigma square. So now coming to the measure of dispersion, we have taken the measure of dispersion only we are going on. So we come to these are the different occurrences, and you can see that here the data is closer to each other, and here it is sparse. Though the range is same, you can see that variability will be different here. Okay. Now coming to standard deviation, as we have seen the variance, from variance we compute the standard deviation. From standard deviation, it is correct one is variance will give you standard deviation, not that standard deviation gives you the variance. This is not correct. Correct one is variance gives you the standard deviation, and we just take the square root and we get it for population and for mean. Look at this n minus 1 here. And then there is numerical problem, we do it. Coming to skewness, what is skewness? Skewness means we wanted to know how this curve of distribution is oriented to one particular side. So this is how skewness is defined as gamma 1, and this is the formulation through which we can find out the skewness. Then kurtosis coefficient. This shows what is the height of peak. This is tail weight. Kurtosis coefficient. So here you can see the peak is okay and tail is not heavier, small. Here the peak is height is long enough, but the tail is also thick. And here you can see the tail weight is also very high, and the peak is also very less. So different kurtosis what we call coefficients will come, which will tell that what type of distribution it is. Now coming to so far this is just a numerical example, so we leave it, move ahead. Coming to correlation. What is correlation? Correlation means if we have a data x and y coming out from a experiment, we wanted to know how x is going to be dependent on y. What is the relation between x and y? Correlation coefficient is 1. It means it is perfectly related, and it's a linear relationship between x and y, positive. And when it is -1, it is negative linear relationship between x and y. And when it is 0, it means it is non-negative. Let us see this example. When you can see it is 1, both are related. It is negative related. And here it is not exactly 1, but some value is there. And in this case, r equal to 0, it means it is not related. So,
मैं अभी आ रहा हूँ, एक इंटरव्यू हो चौकसे वालों का, मेंबर हो.
So why is it required? Let us see. We take another example like the crushing machine. So this is the machine, and in which we wanted to take the data value from here, and there are two data from the machine coming out: grain size as well as the particle weight, grain size as well as weight. So this is the, I think there is some issue. So there is a machine from which you get two data, grain size as well as weight. So weight and grain size may be related and or may not be related. Whenever you take a small grain, okay, the weight is less, and when you say big grain, the weight is high. So you can see that there is a direct relationship between the height and the weight. Now coming to another thing, when you have different materials which are used to produce the grain of that material, since we have taken different material, the density will be different, and you may not find there is a direct implication, direct relation between weight and height. So if you may take a larger grain but may have less weight because the density is different, or you can take a small grain, weight may be high because it's a metallic, it's a wooden. So you may not find a direct relationship between the grain size of weight and height. In that case, both are not related. And in other case, it may be related. So that is how the different data can be related together. Now we quickly come to the probability distribution, and with this we will close. So how to represent the data? Why probability distribution is coming? Most of you may be knowing this probability distribution, but the main point that why do we study this, that I'm going to emphasize and close it here itself. So why probability distribution is required in statistics? Why is it required? Because when you can say that in most of the time, most of the engineering analysis and the real-time system, we don't go with 100% data value. We don't go with 100% data value. Like election, you can see exit polls. Okay, it is not about that you ask to whom you have given weight to 100% of the population. People ask for few of the people, and from that they infer the data that this may happen to 100%. So in most of the cases, we go with a sample. And then we draw the inference from the sample. And this inference, we say that it will be applicable to 100% data. Now this process is probabilistic. This process that whatever you inference is applicable to 100% is probabilistic. So that is why it is required to understand the theory of probability which is applicable. Then we go with the probability distribution, that if you have taken a point from here and the lot was arranged in this way in normal distribution, what is the probability that you are going to this again and again? How many points which are coming here? So these are the different distributions which tells us what is the probability that if you have taken a point away from me this much, how many points and how many times you are going to get this data. So since we are doing a sampling, random sampling, let us say, and that is why the probability is going to be defined here and distribution will be seen. So there are different probability distribution. We normally come to normal discrete distribution, we don't take it. We come to the continuous distribution, in which we talk about normal distribution. So here the parameter is defined in this way. This is the value, and this is called as probability density function, which is equal to 1 when you add all together. So this is how the probability of density is going to come. Probability of that point is lying here, will be shown by here, and this is the value. What is the probability that you get this point here will be given by this one. Now the effect of sigma and mu can be seen. If you have larger values of sigma, the spread will be larger. If you have a smaller value of sigma, the spread will be lesser. If means are different, it will be simply drift from one point to other point. Now, in order to compute the values of probability distribution with different data value, we have to standardize and make it free from mu and sigma. So we make it mu is equal to 0 and standard deviation is equal to 1. This is called as a standardized normal distribution, which is mu is equal to 0 and sigma is equal to 1. And this is transformed in Z frame, and Z is now x minus mu by sigma. Probability distribution is Fz, and cumulative probability value will be obtained by this one. So the charts will be available, or the data will be available for different Z value, which is corresponding to the X value. So this is what is the cumulative standard normal distribution form given here. For different Z value, we can find out the probability. So it is in negative. Negative means we are here. Okay, this is negative value. This is 0, and this is positive value. So if you say any Z value, let us say 1.9. So for 1.9, the probability will be this much. Then you can, just like log, you can move to different point and calculate the probability value. Now, I think we will close it here itself. If any question and answer is there, questions are there, please ask so that we can discuss a little bit more about. Actually, there is something more into this one because of time constraint. I'm not able to take it. So let us start any question or any doubt which is there into this session. Anything which you want to discuss? Yes, participants, please write your doubts and your issues related to this lecture in the chat box. Yeah, I think there is no issue. Everything is clear to all. So I will just go through up to the end of slide and show you that what are the different things which are given. This is about a simple numerical problem. Yes, somebody is speaking. Fine. So I'll just go through that. What are the slides here? Only few are remaining here. So I have taken the example of normal distribution. One numerical example is here. This particular slide is full of, let us say, 20-30 numerical examples are here, which you can see. Then I have taken different distribution like exponential, wave whole, and others. Then sampling distributions, statistics is taken, sample size, and some example are taken from where you can calculate the estimation and other things. Then finally it ends at confidence interval value and internal estimate. So these are the with few examples is given. So and then it ends with T distribution. So actually I will just explain what is T distribution. When we calculate Z distribution, or when we take the whole sample, we create the full curve. But when we take the sample, it is not the correct representation of this normal distribution. So it is called as T distribution. It is not the exactly same population. It is sample, so we called it, instead of sample distribution, we called it T distribution. And for T distribution, if the T distribution, this curve is there, if it reaches to infinite value, you can see it becomes a normal distribution. So that is the T test and T distribution, which is going to be described by this one. The reference for this all was taken by a book from Amitabh Mitra, Fundamentals of Quality Control and Improvement, Chapter 4. So this can be referred for the same examples and the theories. And a few more things were there, but because of time constraint, we cannot take it, unfortunately. But I'll be available online through email. You can contact me and send me your doubts or anything which is there in this area. My email ID is written on each of the slides, so you can contact me. So with this, I close this session. Thank you very much.
Thank you so much, sir, for sharing your valuable knowledge and precious time with us. It was indeed a great session, and we had a great learning experience from you.
Yeah.
Dear participants, we will now start the session of our speaker two, who is Dr. Kumar Abhishek. So before I start with his session, I would like to give a brief introduction to our speaker, Dr. Kumar Abhishek. He is working presently as an assistant professor in Mechanical Engineering Department at Institute of Infrastructure Technology, Research and Management, Ahmedabad, Gujarat. He has completed both his doctoral and master's degree from National Institute of Technology, Rourkela, and owns BTech degree from GBTU, Lucknow. His area of research mainly focuses, but not limited to, modeling and optimization of production processes, non-traditional non-traditional machining, welding, composite machining, and industrial engineering. He has more than 100 publications in various reputed journals and international and national conferences. He is active member of ISNT and IAENG. Recently, he received INSC Young Researcher Award for his outstanding research contribution in the field of optimization in manufacturing sector. I now request Dr. Kumar Abhishek sir to start with his session. Sir, please.
Good afternoon, everyone. Thank you for the nice introduction. And today we will discuss about that design of the experiment, and particularly we will discuss about the full factorial design of the experiment. I think my screen is visible to you.
Yes, sir. Yes, sir. Except for email ID, it's the font color is not visible, sir.
Okay, okay. So, in the previous lecture, that Arsad sir has introduced that basic of the statistic, and I think that most of you have learned about that statistic techniques. So, particularly today, we will start with the design of the experiment. As of now, we can say that in order to understand any process or any process, you have to perform some experiments, and in order to study the behavior of anything, you should first you have to conduct some experiment, and from that experiment you are going to conclude that this is the conclude your results. So basically, if you are think that if any experiment that you are performing, there is a process, and there are some input variables are there which is going to affect your process. Suppose particularly if you think that if you are going for any turning operation in the lathe machine, then what happened that there are some factors such as the speed, feed, depth of cut is going to affect the turning process, and the output that you have achieved in the turning process is that surface finish of the product. And in order to achieve the product quality that is determined by the surface finish, or if you can say that any quality of the process is influenced by the some factors. Suppose if you are going to if you are understanding that suppose if there is the output variable, that is the y, and this is the straight line equation that you have seen, that y equal to mx plus c, that is y is the dependent variable, or you can say that y is the quality or the process that is affected by the value of the x. If and this is the m is denoted as the slope, and whatever the value of the slope is, that if it is the positive value, it means that if you are increasing the value of the x, then the value of the y is going to be increased. Similarly, if the slope that the value is the negative, then what will happen is that whatever the value, if you are expecting that x is going to be increasing the value of the x, then y value is going to be decreased. So in order to understand any experiment, the output product that you have achieved is totally depend upon some input variable. Suppose if I have taken the example of the turning process in the lathe, the surface quality of the product is dependent upon the value of the speed and the feed that you are going to feed on the lathe machine. So So there will be some mathematical function which describes the relation between the input parameters and the output parameters. Okay, then there are some other parameters in the process, or these input parameters that you are going to define. It may be the controllable inputs or the uncontrollable inputs. Suppose if you are looking the example of the turning process, then whatever the value of the speed or the feed you are going to select, you can feed this, or you can set this value into the machine. The operator can have the authority to set the value of the how much speed you want, how much feed you want. These things can be incorporated into the lathe machine, but you don't have the control over the you can say that you don't have the control over the vibration of the machine or skill of the labor. Then these things are considered as the uncontrollable units. क्या होता है कि if the skilled labor is going to operate on the lathe machine for the turning process, then definitely he will produce the surface quality should be the good. If the unskilled person is going to operate the turning operation, then what will happen? Then definitely the product quality may be deteriorated. So you have there are some parameters where you don't have any control. Suppose maybe it will not be qualified as the skilled or the unskilled. Maybe it depends upon the mood of the operator. Sometime if you are in the good mood, then what will happen? You are more focused to the work, and definitely the output, that is the result that you achieve, it should be in the good way. Whereas if your mood is not fine, then what will happen? If you are not in the jolly mood, if you are in the angry mood, then what will happen? If you are performing that experiment, then whatever the result that you are going to be, this will, that whatever the result that you are achieved is not so good. So any process, if you look on the any process, suppose if it is the turning process, there are some controllable units, or you can say that control units, or the over which you have the control. Whereas the uncontrollable units, where the operator doesn't have control over it, and whatever the output is there is the results. Suppose if you are doing the turning operation, then surface or surface finish, cutting force, these are considered as the output parameters. So an experiment involves a test or a series of a test in which he is going to purposeful change that he made into the input variable in order to understand the behavior of the process, so that change in the output response can be observed or the identified. सिंपली आप समझो इस तरह से कि अगर आप टर्निंग ऑपरेशन कर रहे हो, तो अगर आपको प्रोडक्ट सरफेस क्वालिटी ऑफ प्रोडक्ट देखनी है, तो आप क्या करोगे? आप एक टेस्ट ऑफ द सीरीज ऑफ द एक्सपेरिमेंट कैरिड आउट करोगे, वेयर यू कैन चेंज द वैल्यू ऑफ द स्पीड और कंट्रोलेबल यूनिट्स in order to study the behavior of the speed on the surface quality of the product. So for the any experiment, you can, the key elements of the any experiment is the factors or the variables, then its level, or you can say that settings, and the outcome is, that is the characteristic. As I have given the example of the turning operation in the lathe, the factors that is going to affect the surface quality of the product is called as the factors or the input variables. Suppose that is the speed and the feed. If you are looking for the turning operation, the turning process is affected by the speed and the feed. Or if you are seeing the day-to-day life example, then if you have to make the tea, then what will happen? The taste of the tea is the output characteristic, and the making of the tea is the process. Then what are the factors which is going to affect the taste of the tea? That you have to identify. तो टी कैसे कैसे बनता है? जो आप चाय बनाते हो, whatever the quantity of the sugar you are adding, whatever the quantity of the milk you are adding, whatever the quantity of the tea leaves you are adding. So these three factors, that is the tea leaves, water quantity, and quantity of the milk, these all things are the considered as the factors or the variables, as they are affecting the taste of the tea. So this is the factors, and now next we should consider as the levels or the setting. This level or the settings are nothing, it is the quantitative terms. Whatever the suppose if you are making the tea and you are taking the sugar. If you are taking the sugar 1 spoon, 2 spoon, 3 spoon, so these three numeric values, that is the 1 spoon, 2 spoon and 3 spoon, these are considered as the levels for the quantity of the sugar. So you can say that the factors are the or variables are those things which are going to affect the outcomes, whereas the levels of these factors are the whatever the different values that you assign to a factor in order to see the changes in the outcome. Suppose if you are adding the sugar 1 spoon, then definitely the taste of the tea is the sweet. If you are adding the 2 or 3 spoon, then definitely the taste of the tea is making more sweeter. So these are the considered as the levels, or levels are, you should say that the values that you are going to assign the factors in order to investigate the changes in the outcomes. So for the any experiment that you are carrying out, there are the three important things. Is that first is the factors which is going to affect your outputs and outcomes, that is the characteristic that you have to want. Suppose, and for the factors, whatever the different values for that you assigned to the factors. If you look for the some, you can say that if you look for the chemistry lab, so you have adding some for the different iteration, you are going to add some different quantities for the different chemicals. The different quantities for a single chemical is considered as the levels for that factor. So why? So most of the important question is that why should we conduct an experiment? As I have said that first is that determining which variable is the most influential on the response in a study. What does it mean? That suppose if you are making a tea, so there are the several factors are going to affect the taste of the tea. So if you are looking the list of the factors that is affecting the taste of the tea, is the quantity of the sugar you are adding, quantity of the milk you are adding, quantity of the tea leaves are adding. Out of these three factors, which factor is the most significant over the taste of the tea. So for the conducting an experiment, it is first is that determine that which factor is the most influence over the output. If you look in the turning process, there are the several factors which is going to affect the quality of the product. That is the surface quality of the product. This is the output, and factors that is affecting is the speed and the feed and the depth of cut. Out of these three factors, which factor has the most significant effect over the output? So by conducting an experiment, you can assess that these or you can conclude that this is the factor which has and which this is the factor has the more influence over the surface of the quality of the product. This is the first objective of the for conducting the experiment. Second objective is that you have to you have to set the influential x so that output y is the nominal requirement. Suppose if you are making the tea and taste of the tea should be the such that you can enjoy the taste of the tea. Therefore, if you are adding the sugar on the while making the tea, if you are increasing the quantity of the sugar, then what will happen? The taste become the more sweeter. So you have to set the value of the x such that the taste should be the appropriate. Suppose if you are अगर आप चाय पी रहे हो तो अगर आप नंबर ऑफ क्वांटिटी शुगर बढ़ाते जाते हो, सपोज करो अगर आपने एक चम्मच लिया और तो टेस्ट कुछ अलग आएगा. जैसे जैसे नंबर ऑफ क्वांटिटी शुगर आप बढ़ाओगे, डेफिनेटली चाय ज्यादा मीठा होते जाएगा और आप उसको एंजॉय नहीं कर पाओगे. तो आप उससे डिटरमाइन कर सकते हो कितना नंबर हम कितनी क्वांटिटी हम शुगर
Sir, excuse me, you are not audible. Sir, you have mute. You are in mute. Your audio is.
I'm not audible from the last 3 or 4, 10 minutes.
Yes, sir. Since around 4 minutes.
4 minutes.
Yeah, it was muted.
Actually, I don't know how it is muted. Right now, I am audible.
Yes, sir. Yes, sir. You are audible. Yes.
Oh, okay. So actually, you have understand that objective of the conducting the experiment.
Yes, yes. Till then it was clear, and now the screen is not visible.
Madam, now it is visible.
Yes, sir. Yes. Yes, sir. It is.
I am audible or too.
Yes, yes, yes. You are audible, and the video is also clear.
Okay. So the objective for the conducting an experiment is that you are going to able to find that which factor is the more influence over the output, and second important is that you also be able to find that how you are going to set that input factors at which level, so that you should get the nominal requirement of the output. And as I have explained all the things that conducting an experiment is also important in order to minimize the effect of the uncontrollable variables. As if you are conducting the experiment, there are some terminologies are there, and you should learn these terminologies. First one is the response. This is the response is considered as the that output characteristic that you should whatever the output characteristic you want to know when you are conducting the experiment. Suppose if you are looking for the going for the turning operation, then output characteristic that you have achieved is the quality of the product, surface quality of the product. Therefore, surface finish is going to be considered as the output response or the response. If you are doing the farming, then the crop yield is considered as the output characteristic, and if you are making the tea, then the taste of the tea is considered as the output responses. As I have explained that factors are those variables that has going to affect the process, or that is going to affect the output characteristic. As I have said that if you are making the tea, then taste of the tea is the output characteristic, and the whatever the quantities of the sugar, milk, and the tea leaves is considered as the factors. And if you look for the controllable factors, that you have to, on which the operator has the control over the it, whereas where the operator, where it has no control over the parameters, then it is considered as the uncontrollable factors. And as I have explained that label is the refers the values of the factor for which data is generated, or you can say that these are the values assigned to the factors over which you are going to collect the data for your experiment. Suppose if you are considering a time, and for the level for the time 2 hours, if you are doing experiment for the 2 hours, whatever the product that you have to obtain is called as the one output. Second, if you are selecting the time constraint for the 3 hours, then these are the 2 hours and the 3 hours are considered as the levels for the time. And similarly, the treatment is that specified factors for an experimental run. Suppose if you are making the tea, then for how you are going to judge the taste of the tea is that if you are taking the 2 spoon of the sugar and 1 cup of the milk of the 1 cup of milk, then this is the one combination of your experiment and you make the tea and taste the tea. This is the one combination. Second, if you are going to change the quantity of the milk and the sugar, suppose if you are taking the 3 spoon of the sugar and 2 cup of the milk, then what will be the change in the taste? So similarly, this is the called as the treatment. Treatment is the specified factor level for the experimental run, and for that you are going to gather the information. Second is the if you are look here, noise, that is the factor. I have said that you have, there are some parameters over which the operator has not control over the it. Suppose if you are doing the turning operation, then vibration of the machine, you don't have the control over the vibration of the machine. So these are come as the noise, or you can say that in the other word, disturbances. And replication is the replication of the experiment. You can say that it is the duplication of the series of the experimental run. Suppose if you are making a tea, you select the 2 cup of the 2 spoon of the sugar and 1 cup of the milk, you get some result or that some taste. Again if you repeat this process for the second time, then it is called as the replication. The replications is very important for the any manufacturing industry, because ऐसा जरूरी नहीं कि आप जो एक काम करते हो आप सेकंड उसको रिपीट करते हो तो आपको सेम should be the variance in the result. Suppose अगर आप इस सेमेस्टर में अगर आप पढ़ते हो और आपको कुछ जो मार्क्स आते हैं, ये जरूरी नहीं कि आपने इस सेमेस्टर को रिपीट किया तो आप सेम के सेम मार्क्स ले आओ, ऐसा नहीं होता. देयर शुड बी द वेरिएंस. और मैन्युफैक्चरिंग में रिपीटिशन ऑफ द एक्सपेरिमेंट हैज टू बी डन. In the manufacturing industry, in order to minimize the variation over the output. So if you look here example, if you are looking for the, as I have explained in the previous slide also, that if you are looking for any machining process, the surface finish is called as the output response, and speed of the machine and the depth of the cut of the machine is considered as the factors. And there suppose if you are assigning the 200 rpm 300 rpm, then 200 rpm is considered as the low value of the speed and 300 rpm is considered as the high value of the speed. Similarly, if you are considering the 2 mm depth of cut and 3 mm depth of cut, then 2 mm depth of cut is considered as the low level of the depth of cut, and the 3 mm is considered as the high level of the depth of cut. Similarly, if you look for the any popcorn making process, then volume of the yield of the popcorn is considered as the output, and type of the popper and the grade of the corn that you have used in making the popcorn process is considered as the factors. and there are different levels, that is the air and the oil. These are considered as the different levels of the factors. So for the experiment, for conducting an experiment, if you have conducting more experiment, then it will going to consume your time, because whatever the experiment you are doing, whatever the process that you have performed, it will take time, and manufacturers want to save their time and the money. सपोज करो कि इफ यू आर, आप चाय बना रहे हो, तो चाय बनाने में भी आपको टाइम लगेगा, ठीक है। तो जब टाइम लगेगा, तो इफ योर number of the experiment is going to be increased, then definitely it is going to consume more times, और बार बार उसको एक्सपेरिमेंट को रिपीट करना पड़ेगा, then definitely it is going to be going to increase your cost also. So you have to, or you can say that manufacturers want to save their time and cost. So there should be the requirement of the different, you can say that different ways to conduct the experiment. First one is the one factor experiment. Suppose if you are, it is generally happened in the chemistry lab or the pharmacist field, that they consider only one factor at a time. Suppose agar if you are going to make a medicine, so there are the several factors, that is the drugs, there are the several chemicals or the drugs are available. So in order to analyze that effect of the each chemicals over the output, then they what will do, then they generally fix the other parameters, and they in hello. Hello, I'm audible.
Yes, sir. Yes, sir.
Yes, sir.
My screen is visible.
Yes, sir.
Okay. Suppose if you are conducting an experiment in the turning operation, and you fix all the factors at a some level, and you are going to change only the value of the speed only. ठीक है, आप सारे फैक्टर्स को क्या करते हो, यू आर गोइंग टू फिक्स एट द सम लेवल, एंड यू आर गोइंग टू ओनली चेंज द वैल्यू ऑफ द स्पीड इन ऑर्डर टू फाइंड आउट द में करते हैं, क्योंकि वहां पे क्या होता है कि अगर आप कोई केमिकल्स या कोई ड्रग्स आप ज्यादा सिंगल्स ड्रग का अगर आप इन्फ्लुएंस देखना चाहते हो, तो बाकी सब सारे पैरामीटर को फिक्स करके एक का आप फाइंड आउट करते हो, बिकॉज देयर it's a matter of the life. So is the second way of conducting the experiment is the several factors one at a time. In that experiment, what they do is that if there are the various factors, then they fix the values for the each factor and for keep the value same for all the factors, and they find out the output characteristics. Suppose if you look here, if there is the four factors, that is the A, B, C, D, so they all put at the factor 1, or you can say that level 1, and whatever the output that has been achieved, so they will find out this thing. So you can say that several factors one at the time. Then you can say that several factors all at the same time. There is a little bit difference here. If you can look in the second trial, it is, if you look here, this is the sum fact for the level for the factor. So, but most of the factors are at the result. So this is the several factors one at a time, whereas in the second slide, if you look here, all the factors are the same at the same time. That A, B, C and D, all are the factors are considering level 1 for the one time, and they conclude the result. Similarly, if they look for the high level, they considering the 2. So these are the ways to conducting the experiment. However, if you are looking all these three methods, that is the one factor experiment and several factors one at the time, if you look here, that if you want to analyze the effect of the input over the output, and you are doing that one factor at the experiment at the one time, then it is going to increase your number of the experimentation, and which leads to experimental times increase, and also the cost of the experimentation will increases. So if you are a manufacturer, then definitely you are going to save your time and cost. अगर आप कोई भी प्रोसेस हो, कोई भी एक्सपेरिमेंट हो, ऐसा तो है नहीं कि सिर्फ एक ही फैक्टर इफेक्ट करता है आपको आउटपुट पे. कोई भी एक्सपेरिमेंट करते हो तो देयर आर वेरियस फैक्टर्स affecting the process or output. So if you are going to analyze the one factor experiment, then it is going to consume more and more time, but the result will